So transformations and congruence. So what are the three transformations we looked at that resulted in congruent figures at the end of it? Translation, deflection, rotation. What about dilations? They're non-isometric, except in one case. When will a dilation be isometric? Will result in congruent figures. When the scale factor is what? It will be twice as big and therefore not congruent. One, right? Well, what's the point? But it's just the concept you have in your head. If you dilate the scale factor with a multiple of one, right? You multiply anything by one, it stays the same, doesn't it? Okay. So congruence. We've talked about rigid motions, right? Rigid motions are also known as isometric transformations or congruence transformations, okay? And so this is important here. Two figures are congruent if and only if one can be mapped onto the other one by one or more rigid motions, the three we just mentioned, okay? Any one of those or any infinite combination of those, and you'll have congruent figures. And now later on, we will get to the distinction between congruence and equals, okay? So there is a difference mathematically between congruence and equals. But right now, we'll just talk about congruence, okay? So in your own words, how would you know if two figures are congruent or not? What would you say? I'll get you started. They're exactly the same size and shape. There you go. Okay. They are exactly the same size and shape. If the two figures are congruent, what could you tell me about all their corresponding parts, like sides and angles? They're all congruent, right? So all corresponding, be careful, not just all sides, right? I have to say all corresponding, ones that match up between the two, right? Corresponding parts are congruent. When I say parts, I mean sides and I mean angles, right? Basically, parts make the shape. Okay. All right. Now we have this symbol for congruence. We've looked at it before, right? It's the equal time with the little squiggly tilde on top of it, right? That means congruent. And again, we'll get to the distinction between equal and congruent another day or another time, whatever, okay? But we have what are called congruent statements. Now, these are very important to be able to work your way around, okay? They're not just listed out randomly, okay? So what you see here is if they say quadrilateral ABCD is congruent to quadrilateral MNOP, they're both named in such a way so that the corresponding parts line up in order. Does that make sense? So angle A in this one would correspond with what angle in the other one? M. Angle C would correspond with what? Oh, you get the idea? Now side BC would correspond with what? Okay? So they're all in their corresponding parts in the naming, right? So if you're given that, you know that they're in corresponding position. And if you ever have to write one of those statements, you need to be able to put it in that corresponding order. Does that make sense? That is a little trickier, but we have some tricks. Now, from this statement, we can make all of these statements right here, right? So AB, side, that's segment, right? AB or side AB, it's right here. It's the first two, will be congruent to what? Segment NN, etc. Okay? So we can make a list of all the congruent sides, and then we can make a list of all the congruent angles, and that's an angle mark. Now, a lot of times for an angle, if you're writing it, I like to do that and put a little thing in there. You don't have to, but the reason I do that is so it looks like a less than sign or L or something like that, okay? All right, I'll leave that up to you. All right, so we get how we can get these statements congruent sides, congruent angle statements out of that one congruent statement, yeah? So I'm going to have you guys do the very same thing, just part A. I think once you do it once, you'll get it, okay? So I want you to list off the congruent sides. I'll get you started. So for example, AG, and you'll all be using capital letters, right? And not just randomly converting them to lowercase, right? Because that's what they started with. And you'll put a segment symbol above it, won't you? AG congruent to what? H segment HJ, right? Etc. It'll be 3 more, right? Then over here, in this column, you'll do angle A, the angle symbol in front of it, is congruent to angle what? H, okay? So I want you guys to finish these out, top to bottom, right? Right now, on your own, okay? And I'll put mine up in a sec. All right, does everybody look like what I have up there? 3 pairs of congruent sides corresponding, right? Those are the corresponding sides, right? And 3 pairs of congruent corresponding angles. We good with that? Okay? All right, let's go over to the next page. We're going to look at a couple of examples of sequences of congruence transformations. Now, we already know this. Corresponding parts of congruent figures are what? Congruent, okay? Not just all parts, right? You don't just say all sides congruent figures. That means like, okay, in the first triangle they gave you, all 3 of those sides are congruent with each other, and then in the other one, it might be the case, but that's not what we're saying, right? All corresponding sides between the 2 separate, all right? So this first one here, they did a translation. Which way did it move? Right 6 and down 3, okay? Are they congruent? No? Translations are rigid motions, aren't they? Yeah. So no matter where you hold it, it's going to change the size, okay? So here's the congruent statement. Quadrilateral QRST, congruent to UVWX, okay? Now over here, they did a rotation of positive 270, right, which goes counterclockwise, 270. And are those quadrilaterals congruent? Are they quadrilaterals? Are they? How do you know? Four sides. I know, they don't want to ask you. Yes, corresponding sides, right? Hey, by the way, instead of doing a rotation of positive 270, what would be the exact same thing? Negative 270. Or you don't do right left, do clockwise counterclockwise. How about you just use plus or minus? You got positive 270 would be equivalent to what? Negative 90, wouldn't it? Would negative 90 have the same result? Because it's 360 all the way around. Yeah, like 270 takes you over like 3 quadrants, right? Well, I just do 1 quadrant the other, right? Okay. And over there, the reflection of the y-axis, it makes those 2. What are those shapes? What are they called?
Heptagons.
1, 2, no, not heptagons.
Heptagon?
Pentagon, yeah, pentagon. We got 5 sides. Hepta is 7, right?
Yeah.
Okay. Let's come down here then. Here's some examples. So in part A here, we start with this triangle ABC and transform it to HKL, right, or whatever it is. Why did they skip a letter? I don't know, whatever. Okay, so what transformation would you say took place here? Does that look like a reflection? Right, if it was a reflection, it looked like a mirror image, right? Okay, so it's a rotation, right? How many degrees would you say? Yeah. About 0. But anyway, that's not important right now. So now let's get the congruent statement correct, okay? Triangle ABC. We need to get the order correct. Would be congruent to And you know that this symbol means what, by the way? What is that symbol I just wrote? Triangle is simple, right? It looks like a triangle. You use it. If you're going to talk about a triangle, you use the triangle symbol in front, right? So let's get this correct. A, in our original triangle, would map to what? K. Let's be careful. And then B would go with,
Oh, shoot. That's what H.
B would go with H.
No, L, right?
L.
KLH.
So KLH, see? We have to be careful about getting that statement correct. And someone would need to come in later and say, you know, make sure that BC corresponds with LH, right? Okay. Now, how about this other one here? That's either going to be a transformation or a sequence of transformations. What do you think happened? And I don't, so you can just, let's just stick to, we don't need the details of each one, right? Like if it's a reflection, just say reflection, okay? So what do you think happened here?
Probably a reflection and a reaction.
Yeah, well,
Or maybe a reflection and translation.
Yeah.
I think it was just, we got reflected down and then translated. I'm with that, yeah. So a reflection. And a translation. Yeah, for now. Normally you'll be more specific with the details of each right for now. So those are both rigid motions, are they not?
Yeah.
So the figures are congruent and all the corresponding parts are congruent. Let's get the statement correct. So A, B, C, D would be congruent to quadrilateral what?
MCSR.
M. So A goes with E. How do you know it? You're looking at like the side lines, right? Right? And later on we'll have other ways, because sometimes it'll be less clear what goes with what, and I'll have some other tricks for you, okay? So A to B would be like M to P, right?
Yeah,
SR. Okay? And now we have these two, 1, 2, 3. Oh, those are quadrilaterals, aren't they?
Yeah.
Well, what transformation here?
This is translation.
That's all it looks like, right? So that's a translation. And ABCD would be congruent to what?
PYRL.
I'm blocking my letters. Yeah, PYRL. To quad PYRL. Oh, it does that. Okay? Simple enough, right? So any rigid motion or sequence of rigid motions, you'll get congruent figures, and therefore congruent what? Figures are congruent, and their corresponding parts, sides and angles. Congruent, okay? All right. Let's think about this for a minute. Is it possible to be congruent if the sides are congruent but the angles are not? No, because all the corresponding parts have to be, right? Including angles. And same over here. Going to be congruent if the angles are congruent, but the sides are not. No. All right, we have a square or a rectangle. Well, they all have 90 degree and therefore congruent angles, right? Okay.
Wait, so a square is a congruent.
Not to a rectangle.
Oh.
Yeah, see this one, angles are congruent. Yeah, the angles are congruent, but the corresponding sides are not, right? So they figure it.
I thought they were like all like the same shape, like four like different shapes. Okay.
Yep, it's got to be both. Let's go to the next page. I think we get the idea here, right? And we're going to kind of skip past that top part, right there. They're talking about, they did a reflection, then a translation, right? So let's go down here. What I want you guys to do is think about how we can take this quadrilateral here, the purple one, and end up down here at that brown one there, okay? So they kind of do it one step at a time, and maybe you draw in the intermediate one, okay? So this would be the first transformation, and over here would be the second one, okay? I want you all to take a minute and think about what it would be. It will be a little bit more specific here. Like it's a rotation about what's a reflection, what's a reflection like, okay? Everybody take a minute and think about this. What would you guys say probably happened first?
Translation down 6.
Maybe. What else could have happened?
Or we could have translated over the y-axis.
Do what over the line?
I mean, yeah.
Reflection over what? So reflection like this? Okay, that's possible. And then a translation, right? What, could anybody do a different reflection?
Could you reflect it over the y?
Could reflect it over the x, couldn't we? The y equals 0, yeah. Okay. But whatever reflection you started with, you're going to have a different translation when you're done, aren't you? Does that make sense? It's going to be in a different starting point for the translation. So I'll just go with I'll do the reflection in the x-axis. Reflection in x-axis, and it really doesn't matter too much. Okay, so we'll draw that reflection. We use like black ink here. So there's my T, there's my S, R is going to be up there. Q is going to be that, I think. That doesn't seem right. Wait, no, wait. It's my R. 1, 2, 3. 1, 2. There it is. Okay, so we got there, here. Okay, so this would be T prime, S prime, Q prime, and R prime. That seem right? You know, I don't think I want to do that. I don't think I want to do an x-axis. It's going to take too many steps.
I go to the y-axis.
You guys want to do it over the y? We can do this, but let's do it over the y-axis. Right? Hey, look at y'all. That's why we do math and pencil, right? Let's just do it over the y-axis. Now I'm looking at it. I think it's going to. It's doable, but too many steps. So let's try again. 1, 2, 3, 4. 1, 2, 3, 4, 5. Like that. That's 1, 2, 3. 1, 2, 3. T is way back here. Q is at, I guess that should be up here. 5. I'm not going to bother labeling it right now just for time's sake. So let's do a reflection, not the Y, or not the X, but the Y. Yeah, I like that better because now, see how it'll just slide right down, right? So let's do a translation of what? Yeah, it sounds like you're talking about a translation of the details of a reflection. Translation move what right up down.
Oh, but it's a translation down.
Well, let's take a point here. 1, 2, 3, 4, 5, 6, and then what? Yeah, let's do it as a vector. What would it be? What comma what is a vector? Translation. Anybody, go ahead. What would this be as a vector? Translation of what?
5. Or no.
We got to do the x direction first.
Oh,
-1, -1. So down 1 and up 5.
down 5.
-5. Everybody with me on that? Just switch up the notation a bit here. Okay. And those are both isometric transformations. So what can you say about the quadrilaterals when we get done? They're congruent. And what can you say about all their corresponding sides and angles? They are congruent. Are you the only one with vocal cords in here? Okay, it seems like it sometimes. All right, so I have a note for the notes page, but I've already got it in there for you, so you don't have to copy it. We want to take a look at this. So you shouldn't have to write anything down here. Oh yeah, so I guess now we're gonna do the difference between congruent and equals. It's a great time to do it. So if you look here on our notes page, congruent refers to the figures themselves, right? Like triangle ABC congruent to triangle DEF, okay? Or segment AB congruent to segment ST, right? You're referring to figures being congruent. Now, what does it mean to be congruent, right? It means that they have the exact same numerical measure. Now, when we're talking about numerical measurements, that's when we use an equal sign. You get the distinction here? It's kind of a subtle distinction, I guess, right? But congruent is used for referring to the figures themselves. Numerical refers to the actual measurement, say in inches or feet, right? Or degrees or something like that, okay? So, for example, if you see this statement here, AB, what's that symbol above AB? Segment, congruent to segment CD. It's read segment AB congruent to segment CD, referring to the figures themselves, okay? Now, since they're congruent, and we want to refer now to the numerical measure, okay, pay attention. We take off the segment symbol above it, right? When I see AB without that segment symbol, that means the length of segment AB, okay? All math people know that when you take the segment symbol off and just write AB, it means the actual numerical length of AB. And now we're talking about numbers, so I'm going to use what kind of symbol? Equals the numerical length of CD, right? So this is read, the measure of segment AB is numerically equal to the measure of segment CD when it's written like this. Everybody got the difference here? So on your homework, you're going to have to make that distinction, okay? A lot of kids will write, you know, if they want to say segment AB times segment CD, they'll just write AB equals CD. No, that's not exactly it. You see why? Right? And this is all about communicating in math, right? Because math and algebraic symbolism is designed to communicate effectively, is it not? And precisely. Right? So we have to be precise about our language. We're not texting our girlfriend here, okay? Right? We capitalize the first letter of the sentence to a period at the end, and we use the proper notation, right? Now, it's slightly different for angles, okay? You see down here, this says angle A is congruent to angle B, referring to the figures being exactly the same, okay? That means angle A is congruent to angle B. Now, to refer to the numerical measures for an angle, it's a little bit different, right? You see this lowercase m out in front here? What do you think that stands for?
Measure.
The measure of angle A, numerical measure in degrees. Later on radians, right? But right now degrees is equal to the measure of angle B. So the measure of angle A is numerically equal to the measure of angle B. Are you seeing the distinction between congruent and equals? Yeah. And how you adjust how you write it for an equal sign. Like you take the segment symbol off the top of the two letters, right? You're talking about it's 5 inches, right? So if you want to say segment AB is 5 inches, you write AB without the segment symbol on top equals 5 inches. Not congruent to 5 inches. See what I mean? Right? All right, ma'am. We're in chapter 2, section 2.1. Okay? There you go. So, careful to make that distinction, especially in this homework that's coming up, all right? Well, let's go look at some Regis questions now. All right. So let's read over this first one and think about congruent or rigid motions and sequences of rigid motions, okay? So we're going to read this over, and we'll take a look at it. Is there a key word in this question?
Yes.
What is that key word?
Not.
Not. Please don't miss that stuff.
And I think it's 3.
He thinks it's choice 3. What do you guys think? You think it's 3? Let's look at the other ones. The reflection over the x-axis. Well, yeah, that would violate the word not, wouldn't it? It maps it right onto itself, top to bottom, bottom to top. Okay? Reflection over the line x equals 4. 1, 2, 3, 4. It'd fold right onto itself, wouldn't it? How about a 180-degree rotation about the origin? Oh, well, it would just end up over here, wouldn't it? So that's our choice. Rotation of about 40. Let's just check that one. 1, 2, 3, 4. That's its center, isn't it?
Yeah.
Yeah. 180. And it's order 2, so it'll be 180 rotation, right? Okay. All right, let's move on to number 2. Sequence of transformations. Which one would it be? You might think, well, possibly it's choice 2, right? We're just got rotated and translated. But what do we need to check? Remember, I told you rotations and reflections can kind of look the same, right?
Is it translation then or rotation?
Either one.
No, it would be the same.
Whichever. It doesn't, it really, what I'm getting at really, yeah, and I'm glad you're thinking of that, but right now it does, that part doesn't matter, right? You keep thinking that way though. What do we have to check? Check the orientation. Is it reversed?
Right now it is.
One right now. Tomorrow it won't be.
I mean, you have to do the.
It's a PDF file. It's not going to change. You can't edit it. Yeah. No, it's reversed, right? So it goes that way and then it goes this way, right? Which tells you what must be involved. Okay, so it's one of the last two. Why wouldn't it be number 4?
Because it just put.
The orientation would go back to the original, right? It's got to be choice 3. No, look see how they do this though, right? You might be looking at that saying, you get to number 2. Yeah, that looks like a translation by and then a rotation, right? And then you don't bother to look and see, oh, it could be a reflection, and I better check orientation. So they put that first, right? So they do that. Because you're really saying, oh, that's the one. Got to be. Okay? All right, let's move along. Next one. What does the orientation tell us?
It's reversed.
So the orientation is reversed.
So that means it's a reflection. In that case, it cannot
I
be
can't.
2.
Right. That is all true. Yeah. So it's got to be either 3 or 4. Which one is it?
It's 30.
Yeah, it's got to be 3 over the x-axis.
Right, it's all 3.
I don't know. Just cosmic coinkydink. What do we got next? We got this guy. Okay, you're going to need to know something about your lines now. This is the last one. An important word in here. There's many, but you know what I'm referring to, right? Not carry it. Which one? So you're gonna have to test each one of these out. Sketch them in there and test them out, right? Before they just sketch it in.
Wait, carry it on to itself. So, does it,
That's another phrase for map onto itself.
so does it matter? Does it have to be completely on itself? Like,
Yes, exactly. Yes. Yes.
No, no,
Exactly the
no,
way
no,
it started.
I got the answer.
No, I think it's 2.
I think it's 3 again.
2. You think it's 3?
Or 3.
You think it's 4?
It's not.
Who said?
Any takers for 1?
No, definitely not 1.
Definitely not 1. Who said 3? 3 is correct.
Thank you.
Well, let's look at them. So not, right? Reflection over the line y equals x. What is that line?
That is a middle one.
Well, I don't know about middle line, but it's that line, isn't it? It would map right onto itself, wouldn't it? What about a reflection over the line y equals negative x plus 10? Yeah, you all took algebra, right? What's the y-intercept of this line? The b is 10. What's the slope?
X.
No, not x. Slope is never the x.
Sure.
Slope equals negative 1. Well, over 1 if you want to think of rise and run, right? So down 1 over 1, down 1 over, right? You get the idea? That's that line. Yeah, that'd map onto itself. What about rotation about 6, 6? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Well, if you rotate about that point, is it going to map to itself? That's like you can put a nail in it right there, spin it around, right? 180. So that's the answer. What about 5, 5?
That's right, and it's a row.
That's dead. Yeah. Okay. Okay. That is that. So any rigid motion or sequence of rigid motions will result in what? Congruent figures, which of course then have congruent what? Corresponding parts. What are those parts?
The angle and the side.
Sides and angles, okay? Not just all parts, all what?
Angle corresponding.
Corresponding, okay? I mean, it may be all parts, right? If it's a couple of squares, then sure, right? But that's a limited case, okay? All right, well, so if your problem set, we're going to do all of those. Not much. All problems. Now, I want to point something out. Remember, we talked about the distinction between congruent and equals. So if you look at the top of the page there, like number 1, it tells you 2 quadrilateral congruent, right? Angle A, and the symbol is congruent. So what goes in the next spot? Blank. Not just the letter H. Angle, right? You have to refer back to that notes page. Do so. And again, down to the thing, right? JK. There's going to be 2 letters with what over them? With the seconds, right? Now down below there, right? You've got a bunch of triangles and whatnot. Number 4. So now, do you see the measure of angle B equals? You're going to have a number, right? Just now it's a numerical measure. And by the way, to help you with this, what do the angles of the triangle add to? 180. All 3 of them add to 180. All right? I think you know that from somewhere before, right? And it'll be important now, right? So if you know 2 angles and 1 of the triangles on this problem, and you got to find a third one, you just subtract them from 180, right? And you got the other one, okay? And remember, if the triangles are congruent, then the corresponding angles are congruent. So if they don't give you an angle measure, can't you just go over to the other one and find this corresponding angle and get its measure, right? Okay. So go ahead and get started on that.